X equals negative b plus or minus the square root of b squared minus 4ac over 2a. It's a whole bunch of ABCs. It's got X's. It's got a whole bunch of strange things, right? Divisors, square roots, squares, and even this plus minus thing right here. So let's talk first of all about when would you use quadratic formula? Okay, like what's the purpose of it? Okay, is it like the Pythagorean formula when we could use it and we have to use it to solve a certain question, or what's the point of it? Obviously, it doesn't look very easy, so maybe we can avoid using it if possible. If we look at a question like number 1, we've got a quadratic because we've got x squared, we've got equals 0, so everything's on one side, and the bottom line is, let's try not to use the quadratic formula, if possible, right? Let's see if we can avoid using the quadratic formula. Can we just solve this using factoring? Okay, we're able to do 1 times negative 63, which is negative 63, opposite signs. How are we going to make positive 2 out of 63? Well, 63 is 9 times 7. And so if we choose plus 9 minus 7, we're going to be able to solve this question. We get x plus 9, x minus 7 as our two factors. And this is all the review from yesterday. We get our answer, negative 9, positive 7. And that's it. That's the question. I know I was moving really fast, but we don't need the quadratic formula to solve this quadratic equation. Okay? Now, the good news is that the quadratic formula will always work. Okay, so you could always use it for every single question, but we don't really want to use it if we can avoid using it. So for a question like this where we're allowed to factor, let's just factor it and be done. Okay, this is a piece of cake. Now, we have basically a priority now. Okay, we have a priority to do factoring. If we can't do factoring, maybe we'll have to use the quadratic formula. Okay, now, unfortunately, all of these top 6 questions, maybe even top 7, I think it's the top 6 questions, these can all be factored. Okay, it would take us a little while to move everything around, move everything on one side. If you look, for example, at number 5, we would have to move the 24 over to this side. We'd have 9x squared minus 25 equals 0. That looks like difference of squares. We would get 3x minus 5, 3x plus 5. And then we're able to get our answers. X equals add 5, divide by 3, 5/3. X equals subtract 5, divide by 3, minus 5/3. And again, I'm doing these questions way too fast. Those are questions from yesterday. That's a review. We don't need to do those. However, let's look at a question like number 7. Okay. So first of all, we have an issue with number 7. We don't have everything on one side. And if you remember yesterday, we did a question almost exactly like this on the notes where I crossed out 1 and I told you to write a different question. Okay. We need to move this minus 4 to the left. Okay. But we want to be extra careful because this, which is terrible handwriting, let me write it better. This is not good. Do not like this because these two terms are backwards, right? We want this x term to go in the middle. So make sure you can sort that out. Make sure that the 4 is going in between the x squared and the 9 because it has the x. So we get minus 4x minus 9. And now let's talk about this. Let's think about this, right? Is there any way for us to factor this question, right? We need to do trinomials. We need to do 1 times negative 9. We need opposite signs, multiples of 9, 1 times 9, 3 times 3. Is there any way to make negative 4? Definitely not, right? I mean, we don't have a whole lot of options, right? We can make negative 8. That's not going to do it. We can make 0. That's not going to do it, right? No way we can make -4. This question is absolutely stuck. No way to factor it. And so now what we need to do is use the quadratic formula, okay? So what we need to do is use the quadratic formula only when there's no way to factor it. Now, you could use it when you could factor, but it's way too hard and way too difficult. And so let's talk about the quadratic formula, okay? I'm going to rewrite it here so that we can talk about it and look at it. We've got x equals, probably not a bad idea to write it since, especially since we're on the back, negative b plus or minus the square root of 4, oh my god, screw up, b squared minus 4ac over 2a. So this quadratic formula is a very, convoluted thing, but all we're going to do is be plugging numbers into here and kind of trying to simplify it as best we can. So let's talk about what's in here. First of all, we've got A's and we've got B's and we've got more A's and we've got a C. So we've got A's, B's, and C's. And we need to know where A, B, and C are all coming from, okay? On your front side of your paper, you can tell, but basically A, B, and C are going to be the numbers in front of the x squared, the x, and the no x, okay? Now that means getting these things in order are extremely important, okay? I just said a moment ago, you got to make sure that -4 is in between the x squared and the -9. That's also important because A has to be the term with x squared. B has to be the term with x, and C has to be the term with no x, okay? So that would mean, and I would recommend that you do this, especially the first couple times that you're doing a quadratic formula. Let's go ahead and just identify what A, B, and C would be. So A is the number in front of x squared. What number would that be? It's either 0 or 1. It would be a 1, okay? There's 1 x squared. There's not 0 x squareds, otherwise it would look like that, right? There is 1 x squared there, so it has to be a 1. What number is in front of the x? It would be a -4. So really important that we keep track of the negative, okay? Because that negative is important. And then C would be -9. Now, just to kind of show you guys a mistake that people make, these A, B's, and C's are only numbers, okay? We're not going to grab the x squared. We're not going to grab the x, okay? A really kind of rookie mistake is people who put the x squared here. That's not good at all, okay? X squared is never included. It's just the numbers A, B, and C. And so now we need to rewrite this formula, but we need to swap all the A's, all the B's, and all the C's with these numbers that we have here. So let's go through that process. We've got x equals -b. Okay, so we now need to take this b, which is -4, and put it in where the b used to be. Okay, so we've swapped that out. I'm going to go ahead and put my big fraction in here just so I can remember that. Now I've got the plus or minus where they're stacked on top of each other. So I've got that right here. Square root b squared. So I'm going to need this, which is -4. Squared. I'm going to need -4 times a, and a is 1. It's going to be pretty easy. Times c, and a little bit more room here, -9. Now make sure that this all looks like it's underneath the square root, because it all should be underneath the square root. Make sure it's all on top of the the divisor bar here. So make sure this divisor bar is nice and long. And then on the bottom, let me zoom out just a bit. On the bottom, I should have 2a. So on the bottom, I should have 2. Oh, it's a different color green over it. 2 and then a, which is 1. Now, a lot of you guys are super, super smart students. Actually, really, in this class particularly, everybody is a super smart student. You're probably thinking, okay, this just took way too long. All we got to do is swap A, B, and C out, and this took Mr. Collier like a whole minute to do that. Yes, I was going slow, but going slow is never a bad thing when it comes to the quadratic formula, okay? All you're going to have to do is simplify these numbers down. That's it. And so the only thing you have to worry about is rushing and making simple mistakes, right? The only thing you have to worry about is maybe you go to put the B right here and you forget the negative, right? If you don't make those mistakes and you move slowly, you're going to be in decent shape. So now it's time to make this look nicer. Pardon me. It's time to simplify this down and start, for example, 2 negatives makes a positive, right? -4 squared, we can do that. So let's start making these simplifications. Again, trying to be as organized as we can be, trying to, be as neat as we can be, right? Our handwriting is really important here. So the first thing, negative b, which is -4, is going to be +4. Hopefully we're pretty comfortable with that. Some people say negative b, does that just mean -4 and it needs to stay negative? No, right? 2 negatives makes a positive. Okay, then we've got plus or minus. Then we've got the square root. Then we have -4 squared. Again, an easy mistake here would be to say 4 squared is 16, so that should be -16. But we know -4 times -4 is +16. So this number right here is always going to be positive because anything squared is always positive. So we've got 16 here. And then this part is always the hardest part for students, okay? Because you've got 3 numbers multiplied together, and in particular, getting the sign of these 3 numbers multiplied together always, troubles students. We need to have -4 times 1 times -9. Now, the good thing for us is that multiplying by 1 is really easy, right? So this question really isn't too hard. But my recommendation is to say, handle all the signs of it first, okay? We're going to have a negative number times a positive number times a negative number. And so these 3 things multiplied together are going to make a positive number. Because 2 negatives make a positive. Again, I'm sure you guys are comfortable with that. Now, I'm going to multiply the numbers and I'm going to ignore the signs, okay? I've already handled the sign. I'm just going to focus on 4 and 1 and 9. 4 times 1 is 4. 4 times 9 is 36. So this should be a positive 36. You guys are super smart students, right? You can think about multiplying with the numbers. What ends up happening a lot of times is people forget this negative right here, and they just do 4 times 1, which is 4 times -9, which is -36. They forget to include this sign, and they put -36 down here. So what I like to do is just let's do the signs first, and then the number second. 2 times 1, easy, 2. Okay, so we're making really good progress. What's the next thing that we can handle? We can add together the 16 and the 36. So the next thing we need to do, again, as much as we're going slow here, and as much as you might be thinking, can we please hurry up? We're just trying to carefully and methodically move through this and not walk into any silly mistakes. So 16 plus 36 is going to be 52 over 2. Now, let's talk about where we are right now, okay? When it comes to the quadratic formula, the reason we are stuck doing the quadratic formula is because the answers to this equation are not regular numbers, okay? If they were regular numbers, we would find them with factoring, okay? These answers are going to be very strange, decimal, irrational answers, okay? And that means that the square root here is not just going to disappear for us, okay? We're never going to expect to find, 25 here, because that would mean the answers were just regular old numbers and we could have solved it with factoring. So we anticipated that this weird number was going to show up here, that we were going to get a number like the square root of 52. In Algebra 2, our job, though, is to simplify it and continue to make it look nicer, okay? We need to think about square root 52 and how we can reduce that number. And so we have to do something from about a week ago. Square root 52, simplify it. I know some of you are cringing a little bit, thinking, oh, I thought we were past this. I thought this was in the past. In Algebra 2, things never quite go away. Okay, 52 is 2 times 26. 26 is 2 times 13. And we have square root, so we're circling pairs of numbers. The 2's are coming out front. The 13 is left over. And so we're going to have 2 square root 13. Okay, we're here. Four plus or minus 2 square root 13 over 2. And we're almost to our answers, okay? Now we know that the 4 and the 2 square roots of 13, these two things cannot be added together, right? This is a regular old 4, and this is 2 square roots of 13, right? We know that when we add up square roots, we have to have the same exact square roots. So these two things cannot combine together, right? These are stuck, separated. We're never going to be able to add them together. What we do need to do, and this is kind of where it gets a little tricky, right? This is the first time you've really got to think, okay? So far, all we've had to do, plug in numbers. We had to negative makes a positive. That's easy. We had to square a number. That's easy. We had to multiply 3 numbers together. That's pretty easy. Then we had to add 2 numbers together. That's pretty easy. Then we had to simplify this, which is a little tricky, but it's not too bad. The last step is, in my mind, the trickiest step. You need to think about the 4 and the 2 and the 2, okay? You need to consider all 3 of these things, not the 13, because you can't simplify outside numbers and numbers inside of a radical, but we need to think about these 3 numbers and see if we can reduce this fraction down. All 3 numbers have to be divisible by the same number. This one's really easy, right? 4 and 2 and 2. We can divide all of those things by 2. And so our answer, final answer, would be, and I'm just out of room, let's just do it right here. X equals, this would be divided by 2, and it would be 2 plus or minus. This would be divided by 2, and it would be a 1. So I'm just going to write square root 13. And all of that is divided by just a 1. So I'm not even going to write the divided by, because 2 divided by 2 is 1, okay? Now, to be honest with you guys, this answer right here is a nice job, okay? We've done the quadratic formula. We've simplified it all the way. This answer is the perfect answer. This is the answer that shows that you're an advanced algebra, student. And so if you're taking honors algebra 2, you're certainly going to be expected to get this far. A lot of times, if you're taking regular algebra 2, you're also going to be expected to make it this far. On the SOL, they're going to expect you to make this step. So That's it. That's the quadratic formula. That's how you use it. It's literally just, a whole bunch of letters you have to plug in. I want to kind of reiterate really quick that individually, when we were going slow, it was not a complicated process, right? First, we worked in this field, and we said minus minus makes positive. That's easy. Then we worked right here. That was easy. It was 16. Then we worked right here. A little funky, but we handled it. It was 36. Then we worked right here. It was 2. Then we worked right here. It was 52. Then we did the square root of 52, which was over here. That wasn't too bad. Okay? When it comes to the quadratic formula, you never want to think about the whole thing at once. You never want to think about it as one big complicated process. You want to think of it as little isolated things you can make better and go from there. Last thing I'm going to do before we start powering through a few questions here. Very last thing. We need to talk about this plus or minus here. Okay? Now, this plus or minus is extremely important to the question. Even though we basically ignored it, 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 all the way down to the bottom, we never touched it, we never thought of it. What this plus or minus is this is how we know that this answer right here is actually 2 answers. Okay? This is actually 2 answers. Even though we only write it once, it counts as 2 answers. The reason it counts as 2 answers is because one of them is a plus and one of them is a minus. Okay, so this right here actually means 2 plus square root 13 as an answer, or 2 minus square root 13 as another answer. Okay, this plus or minus is 2 separate answers. When it comes to pluses or minuses, we're never really going to mess with them. You don't really need to handle them. You just need to know, as an Algebra 2 student, every quadratic has 2 answers. And even though this looks like 1 answer, it's actually 2 answers. So keep that in mind. Didn't mean to erase my 3 there. Keep that in mind for sure. Okay, the plus or minus. And the reason we have the plus or minus is literally just because we're lazy. Okay, we don't want to have 2 different formulas where one of them has a plus and then the other formula is x equals negative b minus square root b squared minus 4ac over 2a. Okay, we don't want to have to do these 2 formulas. They're the same formula. We'll just solve both of these at the same time. And so we stack both of these formulas on top of each other with this plus or minus. We stack them up and do them at the same time. All right, that's pretty good. Let's do another question. Let's do number 8. So something really important to these questions, a step that we did not have to do, and again, I'm going to go a lot faster on this second question here, is we need everything on one side equal to 0, just like we did before. That's because we can't take A, B, and C if A and B are spread out. We can't take A and B and C if C's on the wrong side. We can't use that. We need everything on one side equal to 0. So let's fix this one up. And I also really like having x squared positive. You guys know I like x squared positive. So I'm deciding to move everything to the right because of this, because I want x squared positive. So we're going to go ahead and do 0 equals 2x squared. On this side, we're going to get plus 8x. That one's still the same. And then we're going to have to subtract 17 over here, and we're going to get negative 18. Now, this is a really good job, right? We've made our everything on one side. That's pretty good. We can get our A, B, C. Here's another pro tip, okay? I'm also noticing that we have 2, 8, and 18, okay? All 3 of these numbers can be divided by 2, okay? We absolutely could do this question with 2, 8, and negative 18 as our ABC. But wouldn't it be easier if we had 1, 4, and 9, right? It would literally just be smaller numbers. So what we would want to do is do the GCF, and really what we can do is we can just divide everything by 2 if we want. It's the same thing now that we have equal signs. So what we can work with on this question is instead of this question, we can get it down to x squared plus 4x minus 9, okay? If you remember from yesterday, we did a question where we did the GCF. We took out a 2. We took out the 2, and then we discovered that this 2 was not going to give us any answers, okay? Only the stuff with the x's was going to give us an answer. And so we don't need to keep this 2 for the quadratic formula because our answers are coming from right here. We don't need this 2 anymore because we have the equal sign. So what I would do is I would go ahead and ignore the 2 and go straight to here. X squared plus 4x minus 9. Now, what you'll recognize is, wait a second, pretty much the exact same question, right? We've got A is 1, B is a positive 4 now, and C is a negative 9. So very, very, very similar to the last question that we did. Hopefully this means we can knock it out super fast, okay? Let's get our A, B, and C. I really recommend that you do this as a first timer. We're going to need 1, positive 4, negative 9 as our ABC. And then we're going to need to go ahead and just start throwing it into the quadratic formula. Now, it's all about managing your space. I have a nice big box here, and I want to use it, as well as I can. I think I might even, that's not going to work. I think I might even try to give myself a bit more room here, right? It's all about organizing and staying sharp, like within your box, and staying well organized. So I'm going to try to work right here using my simplifications down the whole way. So let's work on this. We've got, I'll write it here just so we can see it, negative b plus or minus the square root of b squared minus 4ac. Make sure it's underneath the square root. Make sure my divisor bar goes the whole way, divided by 2a. Now I need to plug it in. Okay, x equals negative b, which is 4, plus or minus the square root of b, which is 4, squared, minus 4 times a times c, which is negative 9. All of that divided by 2a, which is 1. All right, now it's really, really, really similar to the last question we did, okay? We're going to get that now we have a positive 4, so we'll get a negative 4 out front instead, which is a little bit different. We still have a plus or minus. On the inside, 4 squared is still 16. This piece is looking to be exactly the same. We've got 2 negatives, right? Again, I'm thinking about this as minus, positive, minus, and those 2 negatives are going to make a plus. 4 times 1 is 4, times 9 is 36. And on bottom, we have 2. So again, this question is very, very similar. We know that this is going to be 52. We know that 52, I'll just say that, we remember it from last question, is going to be 2 square root 13. And then we know that this number and this number and this number all need to be divisible by the same number. And again, we literally just did this one, so it's pretty easy. Final answer, negative 2 this time, plus or minus square root 13. Very similar question. I know it's a little boring, but always a pretty good, to kind of get 2 easy ones under your belt before you move on. Now let's see some that turn out a little bit funkier, okay? Let's go down and look at number 11 here. I'm seeing number 11. I see that my x squared is negative, and I don't like that. And what I want to do is move everything to the other side to make this x squared positive. I'm going to go ahead and have over here by adding 3x squared, positive 3x squared. I'm going to have to subtract 8x, so it's going to be minus 8x. I'm going to have to add 7, so it's going to be plus 7. Now I need my ABC. Everything's on one side. That's easy. A is 3, B is negative 8, and C is 7. I'm going to get my quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And let's plug this stuff in. Okay, so x equals negative b, which is a negative 8, plus or minus square root of b squared, which is negative 8 squared. I want the parentheses around that. Minus 4 times a, which is 3, times c, which is 7. All divided by 2a, which is 3. Okay, I've got all these numbers in. Now I need to simplify them. Again, hopefully you're starting to feel more and more confident and recognizing that even though this looks like a jumbled mess, we're just going to isolate these pieces one at a time, and it's not quite as crazy as it sounds. So, negative 8, positive 8, plus or minus the square root of negative 8 squared, 64, minus 4 times 3 times 7. Again, I like to do the signs first. That's a negative 4, a positive 3, and a positive 7. So this time, a little bit different, my 3 terms here, it's going to multiply to make a negative number. Now, I'm going to ignore the signs, and I'm only going to worry about the numbers, okay? 4 times 3 times 7. I need to multiply these in any order that I want. I can do, maybe it's easiest if I do these two numbers. 3 times 7 makes 21. 4 times 21 is going to be 84. Again, if you have a calculator, that's really easy. You just type 4 times 3 times 7. You move on. And then we have 2 times 3, which is 6. Okay. Now, hopefully you're starting to recognize that we have a bit of a problem in this question. Okay. We have a bit of a problem right here. We're going to have 64 minus 84. That's going to be negative 20. And negative numbers don't normally scare us, but we have the square root of what is going to be a negative number. And we cannot do the square root of negative numbers, okay? And so if you have been keeping up with us and feeling good all year long, you have just recognized that we're going to have imaginary numbers come back because the square root of a negative is always going to be imaginary. Okay, so now, just like we did before, we need to handle this portion, the square root of 20, and see if we can simplify this. But it's not just the square root of 20, it's the square root of negative 20. And so what I would recommend and what we used to do is I would say take this negative and pop it out front as an I. And then simplify your 20. 2 times 10, 2 times 5. We've got 2 2s coming out front with the I, left over 5. And so this would be 2I square root 5. Okay? 8 plus or minus 2I square root 5 all over 6. And again, this is a really good job, but it's not the perfect answer yet. Can we take all of the outside numbers, not including the 5, because the 5 is on the inside of the square root, and can we simplify all three of these things? These are all divisible by 2, divisible by 2, and so our final answer, let's do this color, would be 4 plus or minus 2 divided by 2 is just a 1, so it would be I square root 5 divided by 3. And that is the perfect answer when it comes to quadratic formula. So, what is the point of the quadratic formula? Okay, the point is not every trinomial is factorable. Okay, not every trinomial is factorable. If you look at a question like number 7 that we did, we could not factor this. We tried as hard as we couldn't do it. So we were forced to use the quadratic formula, okay? The reason it's not factorable is because the answers are not normal answers, right? This is not x equals 2. This is x equals 2 plus the square root of 13. It's just a strange, irrational answer, and so that's why we couldn't find it with factoring. Now, also importantly, sometimes the answers are not only strange, the answers are literally imaginary, okay? And so because the answers are imaginary, of course you can't find them with factoring. You have to use this quadratic formula to find these weird answers that are imaginary. Now that's pretty much the whole deal when it comes to quadratic formula. There's one other little piece, and so I just want to glance at number 9 real quick. We're not going to finish this whole question, but I just want to look at it really quick, okay? When we look at a question like number 9, we need everything on one side. I see that this x squared is negative, so I want everything going to the right. I'm going to have to add the x squared. That will add the 8x squared. So I'll have positive 8x squared. I'm going to have to subtract 7. 4 minus 7 is going to be negative 3. Again, that's just algebra 1, me trying to get everything on one side. Now for this question, again, I could try to factor it, but I would fail, okay? I can't do trinomials because there's only 2. I can't do GCF because they don't have anything in common. I can't do difference of squares because the 8 and the 3 are not perfect squares. I can do no factoring. And so, quadratic formula time, A, B, C. And this is why I wanted to talk with you guys briefly about number 9, okay? A, B, and C, but we've only got 2 things. We don't have 3 things to get A, B, and C from. And so you need to remember that it goes AX squared, BX, and C with no X. Okay? And typically we put pluses here, but you know, these signs might be minuses. So the A has to come from the X squared. So what number is in front of x squared? 8. That's pretty easy. Everyone would get this 8 right. But these two are tricky, okay? We obviously have a negative 3, but is this negative 3 a B or is this negative 3 a C? Of course it's a C. You guys in class are killing it. Yep. Of course it's a C. So what does that mean B has to be? Do we say that it's a 1 or do we say that it's a 0? Because those are obviously the only 2 choices you'd consider. What do you think? How many X's do we have? None, right? There's literally 0 X's. And so we need a 0 here, okay? If you're missing a term, you have to put a 0 there. And that will change things up slightly. You know, I'll get into the quadratic formula just briefly. We won't simplify it all the way down, right? But negative B is just going to be 0, right? Plus or minus the square root of B squared. That's just going to be 0. And it's going to basically not be worth too much, right? We're going to have, minus I guess I'll leave it in there as 0 squared. Minus 4ac. Okay, those actually have real numbers. Divided by 2a, which, again, would have a real number. And so, this 0, which is a negative 0, which doesn't matter, goes away. This 0 here goes away. And so we actually like these questions with the zeros because it means our answers or our simplifications is a little bit easier because we get to cross things out. Okay. And in fact, we really like it when C is 0 because then we can just say this whole thing right here is 0 if that was the case. But anyways, that is the quadratic formula. That is a lot of different things you might run into. It's been a little bit long, but again, the idea is don't see it as one whole complicated picture. Just see it as little parts we're going to handle one at a time and go from there. All right.